Okay, rotations are the most difficult of the three. Graph paper. Rotation, we've already talked about rotations. It's just when you turn something. Okay, put that away. The center of rotation is the piece that it's hooked to. Like most of them that we do on the graphs, the origin is going to be the center of rotation. But there is a few where it's one of the coordinates. So you can think of it as if you hold it tight with a string, and that's the pivot point, and you turn it around. That's the center of rotation.
Okay.
Angle of rotation is how many degrees it goes. Rotational symmetry is something that's super easy, but it's if you don't know what it is, it's tough. They've had it on the MCA test the past few years. So an example of rotating. Okay, most of the time we do just triangles. So, if you had this drawing, and you were going to do I'll just do a 90-degree clockwise rotation about X. So what that means, the center of rotation is X. If you could put strings from B, A, and C to X, and then hold this tight and rotate it a fourth of a turn, that's where it would end up. So the way you do this then is you draw a line. Clockwise is this way. So A is going to rotate up over here somewhere a fourth of a turn. So we got to make a 90-degree angle right there. And then you have to measure. A is going to go from here to here, but it's got to stay the same distance away from X. So we should use a compass, but I don't have a marker in it, so I'll just measure. So there would be the new A prime. If I connected this, these would be the radius of a circle if this circle just kept going around. And it's moved 1/4 of a turn or 90 degrees. So then you got to do that for all the other points. So C So then you got to measure how far C is from X. So there's the new C. And then you got to do B. Put that thing away. Okay, so there we have all the new points. If you connect them, you have the new triangle. That's been rotated. Okay. Now, luckily, we don't have to do any with the protractors. Yours will be just done on an XY coordinate, so it's a lot easier to do. Although, it's a little more confusing to do, just to warn you. Like I told you before, rotations are the more difficult ones to do. Now, rotational symmetry. They're going to give you a picture and they're just going to ask you, does it have rotational symmetry? And if it does, you need to explain it. All this means is you can rotate it a half turn, which is 180 degrees, or less, and it looks the same. So, I'll do a simple one, an equilateral triangle. If I were to turn this, could I turn it a half turn or less and it would look the same?
Yeah.
Yes. So this would just be yes. And then when they say to explain, you just got to say how many degrees you got to turn it. Well, what fraction of a turn is it going to take before it looks the same? A third, right? Since there's three sides, a third of a turn, it's going to look the same.
Yeah.
What's a third of 360? 120 degrees. 360 divided by 3. So if I turn it 120, it looks the same. If I turn it another third, it's 240 and it looks the same. But you only need to have 180 or less. So you only need to put the 120. If it's a square, again another simple one. Does the square have rotational symmetry?
Yeah.
Yes.
Yes, sir.
And to explain, you got to put how many degrees? Each fraction of the turn, it's going to look the same. What fraction would that be? Each 1/4, which is 90 degrees, right? So at 90 degrees, it looks the same. At another 90, it looks the same. And I reached 180, so I can stop. If it was a pentagon, a regular pentagon, percent that's regular, that has rotational symmetry. So to figure out how many degrees it would take, you got to take 360 divided by 5.
Yeah.
So 360 divided by 5 is 72. So at 72 degrees it looks the same, and then we could turn it another fifth. 144, it looked the same. Then we could turn it another fifth, and you'd have 216. But again, you only have to go up to 180, so you just have to list those two. All right? Now, they don't have an example like this in your the rest of this, but in your book, the last few problems, they have like tires. They have rims like that. So they're wondering, does this have rotational symmetry?
Yeah.
Yes. And then to figure out what it is, you just count. There's 1, 2, 3, 4, 5, 6, 7. So you just take 360 divided by 7. So I would have, this one is a decimal, you can round 51.4 degrees. Then you got to do 2/7, so you just got to take that times 2, 102.8. Then it could go another 7th, so you got to add on another 51.4. 154.3. Okay, everyone understand the rotational symmetry?
Yeah.
If they had an isosceles triangle, does that have rotational symmetry?
No.
No. You'd have to turn this completely around 360 degrees before it would look the same.
That's true.
because this point wouldn't be on top again until it went all the way around up to there. It'd be like this thing right here.
Yeah.
This doesn't have rotational symmetry because as I turn it, it still doesn't look the same till I get to there. So this doesn't. A rectangle, does that have rotational symmetry?
Yeah.
How much? Half a turn. So this would be yes. It's just 180 degrees. Okay, once again, a rotation is an isometry. It won't change size or shape. So now we get to the tough part. We're going to take this triangle ABC, rotate it clockwise, which is to the right, 90 degrees about the origin. Now this gets a little confusing, so pay attention on these. If we were doing it this way, A has to come down to here, a fourth of a turn. So if I connected A to the origin, I'd have to make a 90-degree angle, and then A would have to be the same distance away. So it's going to be down here somewhere. Does that make sense?
Yeah.
The way you figure that out without a protractor is you count how do you get from this point to the origin, because that's the point we're going around. It's over 3 and down 2.
Right.
Now I know it's going to end up down here, right? You got to kind of figure out where it's going to end up. You got to do the opposite. So the opposite of over 3 is down 3, right? And the opposite of down 2 is over 2. You got to flip what you're doing. It sounds easy now until you start doing it, then it's easy to forget. Anytime you do a 90-degree rotation to all the points, yep. So instead of over 3 and down 2, I got to go down 3 and over 2. Now when I say over 2, you got to know which way to go.
Okay.
Because I know A is in this quadrant, so it's got to end up down here. That's why I wouldn't go over this way. The way you can check this is if you connect it, it does form a 90 degree, and this slope is up 2 over 3. This one goes up 2 and over 3 also, so you can tell they're the same distance away. So there's my new A prime. Then you got to do that to all the other points too. C is over 1, 2, 3, 4, and down 1, 2, 3, 4, 5. So instead of over 4, I got to go down 4, right?
Yeah. And then over.
So C is going to end up down here. If I connect it here, it's going to end up down here somewhere, right?
Yeah.
So instead of over 4, I got to go down 4. 1, 2, 3, 4. And instead of down 5, I got to go over 5. 1, 2, 3, 4, 5. So there's C prime. Now B, since it's in this quadrant, a fourth of a turn is going to put it in this quadrant. See, right now it's in quadrant 2. So it's going to move to quadrant 1, 90 degrees. So B just goes down 5 and over 1. So instead of down 5, I got to go over 5. And then instead of over 1, I either got to go up or down 1. So is it going to be here or there?
Up 1.
Right, because since it's in this quadrant now, it's going to end up right there. So there is the new triangle. And then you got to always list the coordinates. So the new A prime is over 2, down 3. The new B is over 5 and up 1. And the new C is over 5 and down 4. So there is a pattern for these, just like the reflections we did, that works on 90 degrees. And again, if you can memorize these, more power to you, but they're kind of hard to remember all these little rules. You don't need to remember them, it just makes it shorter for you. The numbers are just going to flip. right? 3, 2, 2, 3, 1, 5, 5, 1, 4, 5, 5, 4. Now this is where it gets tough. Depends on if it's clockwise or counterclockwise. This number switches signs once you flip it. See that switched from negative to positive, this switched from positive to negative?
No.
If it's a clockwise. If it's counterclockwise, the other one's gonna switch.
Okay.
So, it's kinda hard to remember all that, but.
This is first number.
Okay, so here we've got triangle A, B, C. We're gonna do a 90-degree clockwise about the origin. So, clockwise is to the right. So to get from A to the origin, I just gotta go over 2. So I do the opposite, down 2. Does that form a 90?
Yeah.
Yep. So A just went from here to here, 1/4 of a turn, 90 degrees. Really the only ones we're gonna do are the 90 and the 180. And the 180 are easy. Now B goes over 2 and down 5. So instead of down 5, I gotta go over 5. And then instead of over 2, I gotta go down 2. So there you can see if you were to connect this, it forms a 90 degree to the right, clockwise. And then C is over 1, 2, 3, 4, 5, 6 and down 5. So instead of over 6, I'd go down 6. And then instead of down 5, I go over 5. Okay? So the new vertices, A prime is 0, -2. B prime is 5, -2. C prime is 5, -6. Now we're going to do a 90 degree counterclockwise. So it's going to turn this way instead.
So wouldn't they just be negative?
Nope. So A over here, instead of over 2, I'd have to go up 2 because I know it's rotating this way.
Okay.
So there's the new A prime. B I know is going to end up over here. It's over 2 and down 5. So instead of down 5, I got to go over 5. And I know I got to go this way because it's got to come over here. And then instead of over 2, you go up 2. C is over 6 and down 5. So instead of down 5, I go over 5. Instead of over 6, I go up 6.
Careful.
So
Yes.
A prime is 0, 2. B prime is -5, 2.
Is that a little shorter? Like, so ones go to the, like, one square is on the edge.
1, 2, 3, 4, 5. 1, 2, 3.
Oh, no, no.
Nope, they're the same.
Never mind.
And C prime is left 5 and up 6. Okay. Now, I'm just going to do a 180 on this, just so you see it. 180 is a lot easier. So here's the original. If we were to do 180 degree, does it matter if you go clockwise or counterclockwise?
No.
Nope. It's going to end up down here, right?
Yeah.
Because it's a half of a turn. So, when you draw a 180 degree angle, what do you draw?
A straight line.
A straight line. So that's all you do for this. From A to the origin is 2. So since it's 180, you got to continue a straight line. So A would be right there. From B to the origin, it's over 2 and down 5. So you got to go over 2 and down 5. You just do, You don't do the opposites like on a
So you
90.
just like double it pretty much?
Yep, you just double it, because see if I connect it, it forms a straight line. And through the origin.
Oh, you just gotta go through the origin, right?
Yep. And then C is over 6 and down 5, so you go over 6 and down 5.
So really, you could just use a straight edge.
Yes, you could.
Whoa.
So the 180s, you do the exact same. The 90s, you gotta do the opposite. Whatever you go over, you go up or down. Whatever you go up or down, you go over.
Nice.
Okay. Now this one. Looks kind of confusing, but it's not really. If you notice here, this is the original because it doesn't have the prime marks. Then there's A prime, B prime. So what did they do to get this from there to there?
They reflected it.
They reflected it. And then, I don't know if you guys can see, but there's 2 marks there. That's called B double prime and A double prime. That just means they moved the image again. So what did they do to get from here to here? Reflected. So all this is telling you is 2 reflections. If you reflect over 2 lines, 2 reflections equals 1 rotation. To get from here to here, you could have just rotated it right away instead of reflecting and reflecting. And when you describe a rotation, you got to say how many degrees it is. Here they reflected it over this line. Here they reflected it over this line. Whatever this angle is has to do with how many degrees you rotate it. So, here they got actual numbers. It's a little easier to see. Here's the original. They flipped it, reflected it to there, and then they reflected over this line to there. So 2 reflections is the same thing as rotating. That's a counterclockwise. So you'd say rotate counterclockwise. Then you've got to put a degree. 68 degrees?
Yeah.
This is the trick. Like 8, if I connect H to P and then P to H, that's more than a 68 degree angle, right? But it has something to do with 68.
Oh, you subtracted 180.
No,
Add it to 180.
No.
Divided by 2.
it's less than a 180 there, but what do you suppose you do to 68 to find the degrees?
Subtract 3/6. No.
You're doing 2 reflections. You're doing 2 reflections. Double it.
No.
All you gotta do is double it. So it's a 136 degree rotation. So whatever the angle is that they flip it over, you just double that, and that tells you how many degrees it's rotated. And then also, so you gotta say rotate counterclockwise. Oops. Wrote that twice. Counterclockwise. 136 degrees about P. You gotta put the point that it rotates about. Okay, the rotational symmetry. Does this isosceles triangle have rotational symmetry? No.
No.
It would take a half a turn, or I mean a whole turn before it looked the same.
Yes.
And again, you could just turn your book to figure that out. How about this rhombus?
180.
Yes. And to say that, when they say describe the rotations, you just put how many degrees? Half a turn, which is 180. A regular hexagon.
Yes. Yes.
So every 1/6 of a turn, it would look the same. So take 360 divided by 6 is 60 degrees. And then you got to keep on turning it till you get to 180. So the next one, it would be 120, it would look the same. And then 180. Just every 60 degrees. And once you get to 180, you can stop. So, does this picture,
Yeah.
yes,
90.
a fourth of a turn, so 90 degrees, and then what else? Another fourth of a turn, 180. This picture,
Yes. Yeah. No.
no. Since there's no, at this point, it would never look the same until it's back up on top. Okay, the star?
Yeah.
So there's 1, 2, 3, 4, 5. So you take 360 divided by 5, that's 72. And then you got to add another 72, 144.
That's it.
And then that's it, because then it takes over 180. So today's assignment, it's not super long, but it takes a while to do some of these. So we'll work on it in class tomorrow also. Today and tomorrow.
The whole
So it's
class
not
time?
homework.
Yeah, we'll correct them the end of the class tomorrow.
Do you like me?
Hey, how about we start it?
That's why I played football. She threw it to me when it was not so.
Tyra.
Actually, tomorrow, Laurel Johnson's coming in to do something with you. So on Wednesday, we'll finish these in class and then correct them. But I'm going to do the first few. I'm going to do the first few of these with you. So, yeah, do you want a hand?
Yeah, Caitlin, can you give me a piece of that nice paper?
I just want to
Don't care about your role. She's so good. I'll grab you guys. I'll grab
So sorry. Wow, that was perfect. What air?
They don't like me. I have
I forgot one on here.
We had one. Connor wants a written.
I forgot to add a problem.
You wanted Connor.
Did everyone get graph paper? No one needs it? Okay, just so you know, really the only ones that you need the graph paper for are 25, 28, and 29. Now I switched this, make sure you write that down. I forgot to put 25 in there.
25.
Yep.
Hey, you got the paper done.
So, we're going to do a few of these first ones together. Number 6 through 9 are like what you do on this one. If you can draw on it, it helps. I know if you're in your, I forget if you're on iTunes, you can draw, or if it's iBooks, you can draw. 6 through 19, yep. So, for number 6, a clockwise rotation of 60 degrees about P maps R onto what? So clockwise goes this way, 60 degrees. Since this is an equilateral triangle, this would be 60 degrees.
Okay.
So I would just map it onto S. Because each of these are 60, yep. Okay, 7. A counterclockwise rotation of 60 degrees about what maps R onto Q? Counterclockwise is to the left. So again, that would have to go about point P. That would be the point it rotates about. A clockwise rotation of 120 about Q. maps
W.
R onto,
W.
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 so R to Q, that would map onto
W.
W, because there's a 60 and there's a 60. So remember, you don't always follow the outsides. And then number 9, a counterclockwise rotation of 180.
R.
Since it's counterclockwise, it doesn't matter. About P maps V onto R. Because 180 is just straight through it. So, these are yes or no, and if so, describe the rotations, which just means how many degrees. Could you rotate this,
Yes.
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 180.
I think a half a turn, right?
Yeah.
And it would look the same?
Do you want to,
CBS.
do you want to put
half
180?
180, yep.
This is CBS.
180 is the highest you can go.
Yeah, once you get to 180, you stop.
It is cold.
Yes.
Now, this one,
180.
No.
No.
Be 90.
I think it would take a 180, because wouldn't this point have to go all the way up to there?
Yeah.
Sure.
You
Right.
betcha.
Yeah.
I thought 8 is clockwise.
8 is clockwise? Yeah,
It is.
because it's about
Rotating about Q.
Q,
Not
so I'll connect it there and it goes like that to there.
Oh, no, the image inside.
Oh,
And then V,
No.
no.
Zip it up.
So again, now on these, if you could draw on it, it makes it a lot easier.